Hello all and welcome back. So in this video, let us continue our discussion and now let's try to print our linked list. Now in the last video, if you remember, we were able to print our linked list, but we wrote a code which was a lot dependent on this next pointer, right? Now the same is actually doable if our linked list is small, maybe let's say 2 or 3 elements. But the problem occurs when our linked list is, let's say, having so many nodes. Let's say if we have more than 15 nodes, then we are not going to write these 14 dot next and the data, right? That is not how we should print our linked list. So we should have a logic through which we can print any given linked list, right? Now, before we move to the implementation of the same, I would like to first explain you few terminologies and the way normally we have to reach out to any linked list problem, right? So this is the overall structure which we have now seen in the last two videos as well for our linked list. We are given as first node, which is normally we say as head. It is having the address to the second, then second to the third. Each and every of our linked list node is storing some data, okay, the data which is specific to that node, and the address to the next. Now, the very first terminology is the head, right? So we say that this is the head of my linked list, the very first node. First node. Now, normally in questions as well as in every implementation, we will just be given head of our linked list, right? The understanding is that given the head, we can of course get any of my node and work on that. So any logic which you are writing, please make sure that you are thinking with in terms that you will just be given the head. Another node of our use can be the tail node, which is the last node, right? So this big S X here kind of represent that nothing is there, right? So it is pointing to none. Now, tail node actually is something which can help us to solve questions a lot more efficiently. So in many places that this can also be given. But for the time being, if it is not, we have to just assume that we have the head. And if required, actually, we can find out the tail node as well. Okay, cool. So now let's go back to our problem. The problem was that we need to print our linked list in an efficient manner. Like we don't need to write, we don't want to write so many dot next pointers and then print each and every node of our linked list. Rather, we want to make sure that we print it by using some proper logic. So now if we see the linked list, right? If we see the linked list, the way we are able to understand and see it being built in Python, we had our head pointer. We had a head pointer which was focusing here, right? Now, the very first data, of course, we can simply get if I just write head dot data. So this is going to give me 1, right? Now the approach again is same. Given any problem, just like we were doing previously in recursion and other modules, we have to just think that what will be the solution and how I can now grow to that. So solution is going to be something like this: 1, 2, 3, right? Now to go to the next node overall, I used to write head dot next, right? That is how I was writing the same. But what I can do is I can ask my head that, hey head, can you please go and point to this node instead? So instead of pointing to the first node, can you just go and point to the second node? Because I need to access the data of that particular node, right? But how can I do that? I think I can do that by using this code. Head is equals to head dot next, right? So I'm just saying that the head is now pointing to the second node. And if I'm on the second node, I can actually just do something like this: head dot data. And this time, because I am on the second node, you will see that we will be able to print 2, right? In a very similar manner, if I now do head dot, head is equals to head dot next, then I will be reaching out to on my third node, right? Now with this step, I will be reaching out to my third node. 1 second. Great. So once I'm on my third node, then what can I say? Head dot data, like I'm printing all of them, and I will be on my third. right? So using this, I see two things that I'm able to actually print my data, right? Print each and every node. The second thing is that there is a lot of repetition here, right? This is the same code. Then again, this is the same code. Then again, in the end also, I can ask my head to point to head.next. Now again, here we will see that yes, this is none, this is none. So we should ideally stop. We should ideally stop when my head is none, right? The reason for that is if you have none in your head, right? If you have none in your head, so let's say if your head or any pointer for that matter becomes none, then this is very, very important with context to your linked list, and I will write that as well. We cannot use dot data or dot next on my none. Okay, now why I have written this specifically is that this is going to be the most common error which we face when we try to work on linked list. We have to always and always ensure that we are not calling none.data or none.next because none is nothing. Okay, so asking like nothing to give you something, that's a problem. I can show you that as well. So let's say if I am, let me just create this node. So to show you this error, because you have to always remember this. Let's say if I'm just copying this data and I have everything till now. If let's say I'm creating a node, so third is having this, right? Third is having none in the, this is the same, right? Third is having the next as none. So if I now do print third dot next dot data, now third dot next is going to be none, and this is going to be, I'm calling something on data. Now if I run this, you will see that it is showing you an error. Attribute none type object has no attribute data, right? So this is very, very important to understand. Any code you write, okay, I will actually just make it a lot more readable. Always avoid accessing anything or rather any property on none, right? So again, very, very important stuff. So we will have to keep a check. We will have to keep a check that our head should not be equal to none, right? So coming back to our problem in hand, we see that we are able to repeat lots of lines. And if so much lines we are repeating, then again, loop can very fabulously be used. So let us now try to code this as well, everyone. I hope the overall understanding is clear. We are going to see the same visually as well, so don't worry. Now, if I go back here, what I have to do, let me just comment this out. What I have to do is, let's say I'm creating a print underscore ll function. Okay, print linked list, and I will just be getting my head. So that's how we will be thinking about the problem. Already I've cleared that. We will just be getting the head. What can I say is while my head is not equal to none, right? While I'm saying my head is not equal to none, and it should be a function. Yeah. Please print head dot data, right? And head, can you please point to the next now? Can you go to the next overall node now? And if we do this, and let's say once we have done this, we can return because again, we are just printing something here. We don't have to return anything. Then I think this is going to work fabulously well. So print ll head. Yeah. And we see that we are able to get our output. Okay, great. So let us see this once in working as well, everyone. Yeah. So what I'm doing is I'm just copying this code in Python tutor and I'm just calling the same with head. Now we have deleted all these things. We already saw how the input is going to be. So let me run this. Now let me just bring it to the point where we have gotten the input. Yeah. So I've just jumped first 24 steps. Okay, we saw this already in the next in the last video, where in my head I was just having these things, right? So this is a very good visualization of linked list. Now let's see how this particular code is going to run. Okay. So what is the last line which I've run? So I've deleted some these first, second, and third, and showed you that how still I have everything intact. So I have the second node, I have the third node. just the reference to this is deleted. Okay, so when I delete second, when I did actually this delete second, just the reference to this node got deleted, not the node itself. Okay, the node is still there and I have the reference in this. Great. So yeah, now let us move forward. The function is going to get defined in my memory. And when I call this function, then let us see what's going to happen. The very first understanding is that this head, it's a local variable, like this new parameter is going to get created, which will be different from this head, right? Now, if I try to run this, it's going to see first if the head is none. I don't think that the head is none. It is saying that it's node pointing to this node, right? So let us move forward. I'm printing head.data and I see the one got printed here, right? Great. Now I'm saying head is equals to head.next. Now always remember this is the head I'm talking about. This head will remain unchanged, right? This particular head will now actually move to this node. So let me just execute it. Yeah, see, head moved to this. So see how the pointer is changing, right? All the game in your linked list is about the pointer and the visualization. I'm that's why putting so much effort in explaining each and everything to you via this particular approach. If you are able to understand this once, believe me, you're not going to face any problem. Okay, so I've just removed this head as well so you don't get confused. Now this head is there pointing right now here. Let me just point it to the next one. Okay. Now, if your head is pointing to this node, of course we can access the data, right? We can just do head dot next. Sorry, head dot data, and I will get 2 here. Now I have printed this node. I just have to make sure that I move to the next node. For that, if I do head is equals to head dot next, and let me just remove this again. Okay, second, yeah. Now you will see how the pointer changes again. See, initially it was on second and now it is on third. Okay, so at each and every step, it is very important to visualize that what exactly going to happen. 90% of the question in linked list can actually be just solved by drawing the linked list. It is that easy. So now we have to again print the data. And in the very next step, now see what's going to happen. Head is equals to head dot next. My head became none this time. And because my head is none, I need to make sure that I come out of this loop. Once I come out of this loop, I'm going to return and I have my linked list printed, as well as this information is saved in my head as well. This information is saved still. So I just sent this as a parameter. Okay, so a copy was made. My this head was not changed. Okay, everyone, I hope this is clear. So this is the way we can print our linked list. Now, one thing I would like to change. Let's say what if I want to change my, print my linked list 2 times. Then many of you might say that, yes, let us just print this again, right? So I've just copied the logic to print my linked list. The requirement is that I want to print my linked list 2 times. Okay. So let me run this now. Okay. Okay. So we are getting just the linked list elements just 1 time. So good point to pause the video and think about it once. So if you must have think about this, and I'm pretty sure just by using the visualization, the way I've explained you this, it should be a lot more clear. What happened is that my this head is actually none only. This head in the previous loop have become none. So that's why I cannot now write any more logic on this. I have actually lost my head inside this particular function. So if you would like me to do anything, if you would like me to return this head, then is also I'm going to face a problem, because as we see here in the last step, I lost my head here, right? Either you have to send it again and you cannot do that in mid of a function. Okay, so that's again a very bad approach. Okay, to use directly the head which we are getting. What we should rather do is we should always make sure that we are creating a temp variable. Okay, so this temporary which we are pointing to head, and instead of head everywhere, we should just make sure that we are using this temp. Okay, so let me just copy temp everywhere. And now you can imagine what's going to happen. It's very simple stuff. Just that because I have this head saved with me, okay, you can create a temp to here as well, not a problem. Because I have this head saved here with me, I don't need to worry on anything, right? I can be very, very much sure that will always have head, no matter what all logic you need to write in your function. So again, this thing is very, very important. This is where many students make the mistake. Once you lose your head inside this function, there is no way you can recover it. Like once I lose this, even once I actually go to this second node, I cannot go back, right? This is one thing again you have to understand. In this linked list, you cannot go back to the first element from your second element, right? So always make sure that you're making the copy. And now if I'm going to run this code, I will see the linked list printed 2 times. The reason is that I still have my head with me. If I just keep on following this particular logic, I can actually print it any number of times, provided I don't lose my head. Okay. So in linked list, please make sure that you are not writing logic wherever you are losing your head after your logic ends, right? So that is going to be a lot helpful. And we are always going to create some variables like this temp when we are working on our code. Great. So yeah, I hope with that this is clear. Now in the next assignment which you're going to get after this class, after this video, you have to do the same thing. You have to print your linked list, but you have to do that recursively. Okay. Again, it's going to be a lot easy. Just always remember the steps which I have taught you in recursion, and you will be able to do the same. Okay. So cool then everyone. I hope this was helpful. Let's meet in the next video. Thank you.